All right, so let's look at this question here. So if sine x equals 2 over 7 and x is in the first quadrant, determine the exact values of the following. So here I have sine 2x, cos 2x, and tan 2x. Okay, and there's different things here that I might be asked, right? I could also find even just cos x or just tan x, and maybe I'll do those as well, just to show the full progression of all the things that we can solve when we have this type of question. So first of all, it being in the first quadrant is important. It's telling me where to draw my line and what values are positive and negative in this triangle I'm about to draw. So they could say it's an acute angle. That would also mean it's in the first quadrant, because that would mean the angle is less than 90 degrees. So I know that sine x equals 2 over 7. Well, our regular trig ratios, sine of an angle is opposite over hypotenuse. So opposite is 2, hypotenuse is 7. So now what I need to do is I need to find that adjacent side, so I have a complete triangle to work with. So this is going to be Pythagorean theorem. I'll go a little quick through this, right? I know my hypotenuse, c squared minus b squared equals a squared. 7 squared minus 2 squared equals my x squared. So 49 minus 4 x squared. So I'm taking the square root of 49 minus 4, 45, equals x squared. Sorry, that would just be x then. And the square root of 45, it doesn't work wonderfully. I get a decimal. It's like 6.7 something. So that equals x. But I think we can reduce the square root of 45. And it is best practice to reduce this as much as we can. So I'm just going to do that on the side here. So I like to reduce my my radical through prime factorization. Now you might do it a different way. End goal is the same. I want to reduce that radical. So I'm going to do some factoring here. So 45, I know I can divide that by 5. And I'm going to get 9. And you know what, actually, right here, I am good. I'm going to stop because 45, the square root of 45 equals the square root of 9 times 5. Well, I can break this up over that multiplication symbol, and the square root of 9 is just 3. So square root of 45 is the same thing as 3 root 5. Now that's just more simplified. We like more simplified in math, and that's what the question will be looking for, is root 5s, not root 45s. 3 root 5. And this is a bit of a review back from Math 20 is when we look at this mainly. A little bit maybe Math 10, but Math 20. So if I just fill in the cos and the tan, even though I wasn't asked to do those ones, well, sine, we know that's 2 over 7. That was given to us. Cos would be adjacent over hypotenuse, so that is 3 root 5 over 7. And tan, opposite over adjacent, that'd be 2 over 3 root 5. And yes, we'd probably want to rationalize that denominator, but I will leave it like this for now. Okay, so what the question is actually asking is for double angles, so sine 2x, cos 2x, tan 2x, etc. So to get that, I need to look at my double angle theorems. And the sine one is the most straightforward because I only have one option. So I'll do that one first. Maybe I'll just change colors here, go in green. So sine of 2x is this is right from my formula sheet. 2 sine x times cos x. Okay, well 2 sine x is 2 over 7, and cos x is 3 root 5 over 7. And this is 2 over 1. So we just multiply this out. 2 times 2 is 4, times 3 is 12 root 5 over 1 times 7, 7, 7 times 7, 49. All right, so sine 2x is 12 root 5 over 49, just like that. And before I do my cos, I am going to rationalize. I'm going to go back. I'm just going to rationalize this tan x so that it is proper when I'm working with it. So I have 2 over 3 root 5. Right, I would need to multiply that by root 5 over root 5. So I'll end up with 2 root 5 over 3 times 5. So it's 2 root 5 over 15. Right, and that is, again, that's just tan x. So that's just tan x with the rationalized denominator. Okay, let's continue. I'll go purple and look at cos. So cos 2x, I can choose which one I want to do now. And honestly, it doesn't matter. Regardless of which one you do, we'll get the same answer. Is one particularly easier than the other one? Not really, because I know my sine, tan, and cos x. Really, it doesn't matter. I'm going to go with the first one. Cos squared x minus sine squared x. Okay, so cos of my angle, that is 3 root 5 times 7. So all that squared, and then minus sine squared of my angle, which is 2 over 7, and squared. Okay, so now I am squaring everything inside of it. So I'm going to have 3 squared times root 5 squared. So I'm just going to go 3 squared times 5 over 7 squared, which is 49, minus 2 squared, which is 2. Sorry, 2 squared is 4, over 49. Let's simplify this one more step. 3 squared is 9, and 9 times 5 is 45. So this is 45 over 49 minus 4 over 49. I have common denominators, so I am super happy. And my cos 2x is going to be 41 over 49. I can't reduce that fraction, so that is my fully simplified answer. Now, if you did cos of the double angle as 2 cos squared x minus 1, or the other one, you're going to get the same answer. And that's how we would do it. That's how it works. And let's look at an orange color, and let's do tan. So I only have one double angle identity for tan, so that makes things easy. I don't have to choose anyone. And it's 2 tan x over 1 minus tan squared x. There we go. So tan is always a bit more annoying to work with. We got more fractions. It's not as much fun. But this is right from your formula sheet, and we just keep plugging stuff in. So 2 tan x. So that's 2 over 1 times, what was tan x? Let's go with this one, our rationalized denominator. 2 root 5 over 15. And all of that over 1 minus 2 root 5 over 15 squared. Ugh. We just got to keep working it. So let's work on the top a little bit. 2 times 2 is going to be 4 root 5 over 1 times 15, 15. And over here, I've got 1 minus, well, 2 squared is 4. Root 5 times root 5 is 5 over 15. Okay, 4 root 5 over 15. This one here, I'm going to do a few things in one step. The 1, I'm going to write that as 15 over 15, and then minus 4 times 5, 20 over 15. Okay, and now I've got here, we're getting close, 4 root 5 over 15, all over negative 5 over 15. Okay, and now I've got a fraction over a fraction, so I would need to flip and multiply. So these all cancel out, and I'm going to be left with well, my 15s cancel. 4 root 5 over 5. So that would be my, negative 4 root 5 over 5. So that would be my tan 2x. Sorry, I am going to have to go back here. Because I didn't square the denominator. I didn't square the denominator divided by 15. I got to square that 15 there. So 15 squared. There we go. That's what we were missing. 15 squared is 225. Okay. So now we keep going. 4 root 5 over 15 divided by 225 over 225 minus 20 over 225. All right, 4 root 5 over 15 over 205 over 225. And now we flip and multiply, so 225 over 205 to get rid of that double fraction. These cancel, these cancel. All right, so now before I finish, I know 225 is divisible by 15 because 15 squared is 225. That's how I got that. It's going to cancel this off and be left with 15 on the top. So 4 root 5 times 15 over 205. And 4 times 15 is 60. So I've got 60 root 5 over 205. I need to see if this is going to simplify any further. And well, at first look, 60 divided by 205, I don't get a nice number there. You might think it doesn't, but I can see both of these numbers at the very least are divisible by 5. So I'm going to divide sort of the top and the bottom by 5. And I might have to do that again, but we'll see what we get. So 60 divided by 5 is 12. So I'm going to have 12 root 5 on the top. And 205 divided by 12, I would get, 205 divided by 5, I'm going to get 41. 12 and 41 don't have anything else in common, so that is my final answer for the tan. Right, the tan double angle, it's a little bit less fun. It's lots of fractions over fractions and some common denominator work and squaring stuff. Less fun algebraically, but you're given your formula. There's no choices. You've got to use that one, and you just work through the steps. Take your time, double check with your calculator, and you'll be just fine. All right, if you still have any questions, please don't hesitate to reach out.